Right, we're going to finish talking about the front suspension in the Mondeo Mk3. In other words, I'm going to finish replacing all of it with the struts and the shocks in this video. I did the control arm before, and I'm also going to do the drop links, which just about completes everything of relevance in the front suspension. So after I did the control arm, I was still getting some clunks when I was braking and going around like a right-hand corner sometimes when you brake too hard. So yeah, not good. And as you'll see, it certainly needed replacing.
You can inspect shocks a little by looking. In my case, I knew that the springs were getting on because the car was sagging at the front. Now, this happens with age as the steel just creeps, and also there are supposed to be a boot and a bump stop, which are basically just gone here. So you shouldn't be able to see the piston of the strut there. It should be protected behind a black boot, and that orange dust is what's left of the foam bump stop. I'll show you what that's supposed to look like later on. Here I'm turning the wheel. Because these are the front wheels, the whole shock has to turn, has to rotate as you steer. So there's a bearing mount up there which allows the whole assembly to rotate with the steering. And sometimes you'll get noise out of that action when the bearings or the mount is shot. And this isn't too bad, but of course the inspection is limited by the fact that there's no weight on it once you've lifted the car up to do this. You can also look at the top. You can see this moving around as the rake or the caster changes with the steering angle. If they're really bad, you could grab the shock underneath and sort of actually wiggle this around. Any free play or noise that you get from that would obviously mean that the top mounts are gone. The first thing I did was soak this clamp joint at the bottom of the strut with penetrating oil. It will need disconnecting later no matter what, so I did the bolt and the joint. If you drive on salted roads, this is the sort of bit that will give you grief with rust, so good luck. Up the strut are these two 15mm nuts to undo. The one which is harder to access is the brake line bracket. The bolt is integrated into the bracket, so it's simple to action. On the other side, it's also a 15mm nut, but this is where the drop link ball joint attaches. So once it's cracked loose, it'll probably need holding at the spindle to prevent the ball from rotating as you try to undo it. I used an Allen key and a ring spanner like this, but it would be smarter to either use a ratcheting spanner or put a hex bit on a ratchet handle and just turn the ball against the nut. I did work out that I could jam the key here against something to hold it. Anyway, once it's off, the drop link spindle will just push out, but keep your fingers clear just in case there's any tension on it and it wants to move suddenly. And I put the nut loosely back on the spindle and rotated the link out of the way. Then I removed the ABS sensor. There's a little tab you can depress with a screwdriver and it should just pop off. And next, the brake caliper. I think the workshop manual, the Ford workshop manual, instructs you to take off the whole carrier assembly with the caliper with it. But there's no need for that, and those bolts are much tighter than the calipers. The need is to allow the wheel hub to be dropped off the strut, and the brake line doesn't have enough slack in it. So I just removed the caliper, and I used this S-shaped hook I made up to just hang it to an edge of the wheel arch plastic lining. Normally I would hang it off the spring, but obviously that won't work this time. It just needs to be secure and out of the way without any stress on the hydraulic line, and the rest of it can stay on the wheel. Or it might be a good time to do a brake job while you're in there. You need to disconnect the bottom ball joint to take out the suspension, no matter how you do it. And sadly on these cars, to do that you are supposed to lower the subframe, otherwise you stress the control arm rear bushing too much. If you don't lower it, you could damage it. It's a pain, but it does also make the ball joint easier to take out. To lower it properly, you should also disconnect the steering column from the rack. I covered this in a previous video on changing the steering rack, so here is Craig from a year or two ago to cover old ground. So to start that process, the first thing to do is to disconnect the flexible steering shaft inside the car. That's just a small hex. It might be quite tight though, so use a good quality socket on it and remove the little bolt fully. Once it's out, the shaft fitting is hinged and it rotates away from the triangular stud, like so. And now the rack outside is mechanically disconnected and can be lowered down. To do that, I'm talking about lowering the whole front subframe, which is a little project, as you'll see. To do it, you'll need to work the big boy 21mm bolts in all 4 corners. This is one of the rear ones. They go straight up through the big bushing into the chassis. I did spray these with penetrating oil a few days before trying to turn them, as if you look online, you'll find many lachrymose tales of these bolts being seized in efforts to turn them, instead ripping apart the threaded bit inside the car, after which they'll just turn forever and you won't be happy, because you will have to cut into the car from the top to get access to all that. It also happens that my jack handle makes a nice cheap bar. Slightly ridiculous, but it works. Just make sure that your socket is good quality, preferably a 6-side hex, and it's on the bolt head dead square so as not to go rounding it. And all I'm doing here to start with is loosening them all, just to check that they do crack loose at first. Now the front ones are reset up higher next to the wheel arch, and by the way, obviously I've taken out the plastic liner inside the right hand wheel well here. So these bolts you can sort of access directly from the side through this opening, but there won't be much room to actually turn them if you try that, so it's best to have a decent 12 or 18 inch extension bar, and you go up from the bottom like this, and then you've got all the room you want for swinging the cheap bar around. Now once I'd cracked all those loose without breaking anything, the front ones do want loosening just a few turns. I'm not actually undoing these. All I'm doing is slacking them off enough to allow the frame to tilt down from the back without stressing anything here. So you just want to open up enough of a gap, see here, between the bushing, just to allow a bit of a pivot. Don't do too much or you're going to risk damaging the bolt threads that remain, because the weight of everything is still hanging on them. Also the radiator and some other bits are sitting on the subframe, and you can't lower it much more than this without disconnecting all that. Then the lower engine mount, rather the torque restrictor on the gearbox, that needs to be disconnected because it attaches to the subframe. I took out the front bolt, but as you can see it doesn't swing loose until you also loosen the rear one. Now, this makes it easier to put back later too. And then the engine will swing a little bit loose, but it's okay. And then the last step is to disconnect this plug, which is for the downstream O2 sensor on the exhaust. I unplugged it, but also freed up the cable that was clipped to the frame so that it won't get caught up. Okay, to actually lower the frame here, you'll need some bits and pieces. I scavenged a bit of 2x4 pine that was ideal, and you can see I used the car's roadside manual scissor jack. You want to put that beam back across the subframe, but far enough forward that you don't block access to the bolts and the brackets. And then put the jack dead center. Measure it if you want, and lift it up until there's weight on everything. Now you don't want to try to lift the car obviously, but you want enough support that you know that the frame is supported and it won't move when you take the bolts out. You want to make sure it's all good and solid, and nothing will be prone to slipping or getting kicked out accidentally. And then when ready, the bolts can come out all the way. Now just watch as you turn them that the bolt head comes away from the bracket and that the frame or bushing isn't chasing the bolt down as you turn it. That's to say that you can see here the wood is obviously taking the weight okay. And once that the main big bolt is out, then there are these additional 2 small bolts which hold on this tie bracket. They need to come out, and that bracket removed before the subframe is actually free. And then once you're 100% sure that everything is actually disconnected and clear, you can start to lower the jack. I'd go slowly and just keep an eye on anything unexpected or any weird noises. You want to lower it as much as possible, but eventually the flexi joint on the exhaust will take up and it won't go anymore. If you get that far, just back it up a few turns on the jack so that the weight is back on the beam, and then that's it. Back to the strut then. The clamp joint bolt is only a 15mm hex, but I know it can get stuck in there. I didn't have any trouble. My car is usually quite good and things are not really seized. All I can say is use penetrating oil, maybe heat, and alternate tightening and loosening as you go. I see a lot of people disconnect the axle from the hub, and they take the whole lot off with this joint still connected, with the idea of attacking it on a bench. But that ups the job to fairly heavy-duty tools, and as I'm showing you, it's definitely not necessary. There's my bolt, good condition. You can see the factory original thread locker. Now, before trying to get it apart, the ball joint will need disconnecting. This is the other fun part of the job. I did the control arms recently, and I have a video on the whole thing if you're interested. That's why this arm looks new. This time I just needed to disconnect it. The pinch bolt here is a T55 head and a 18mm hex nut on the other side. To pop out the ball joint, I've found that my half-inch breaker bar here is just sort of perfect to fit in and just pry it down, being careful of the ball joint rubber boot. You don't want to crush it. This is why the subframe should be lowered, by the way. You can see how this extra distance might overflex the bushing on the other end of the arm. Once I had it out, I used a rag to protect that boot because there's a heat shield right next to it which would quite easily cut it given a chance. And what I'm trying to do here is just get the wheel assembly forward of the arm so that there's enough room for it to drop down off the strut. That's all we need to achieve. The problem is that the top mount resists that movement, so to help, I went up and started on these top mount nuts which retain the shock at the top. I didn't want to take them off just yet, but I loosened them so that the shock could swing about a little easier. Next I had to have a go at getting that clamp joint off. There is a special tool to spread the clamp. It sort of looks like an Allen key, but what it really is just a bent rod with flats on the end which insert in the gap, and it works like a cam, so as you turn it, the flats turn into the larger dimension of the diameter of the rod, and it opens the joint up. So I made up my own version using just a cheap bolt. I think this is a 10mm, and I cut off the thread section, so I was just left with the round rod shoulder, and then I ground these flats into two sides. I took about 1mm off each side so that the flat insert is about 8mm across, I think. It just needs to fit into the gap, and then I turned it 90 degrees with a spanner, and it worked great. You can see that the joint open up there, and it just stayed there while I worked it apart. You see people hammering on this without spreading the joint, but I think that's pretty dumb. It's definitely not going to want to let go easily, and you're effectively smacking hell out of your wheel bearing and CV joint, etc. So yeah, don't do that. So as this goes down, it has to clear the arm. I had to stop occasionally and check that it wasn't getting stuck up. On the other hand, you don't want it to fall off completely because of the CV axle. And the steering helps retain it if you've left the steering connected, but do be careful anyway. And once it was loose, I just had to finish taking off the top nuts, keeping a good hold of it with one hand, and I was halfway finished. Now it's hard to see, but I put a block of wood under the control arm here to help support the weight there. Now that the strut's off, obviously all of this is just resting on the control arm. As I said before, we don't want to go damaging those bushings, so a bit of support for the weight is good. I've got a towel in there too to protect the CV boot. So this old shock is pretty clearly showing its age. I mean, it's 22 years old and over 200,000 kilometers now, so it's to be expected. I was particularly interested in the top mounts because I was suspecting them of the noise. You can see that rubber is pretty old. Here are the new mounts I bought, and they're so different at first glance that I was worried I'd bought the wrong size. Notice how the old rubber is so compressed down, it's completely crushed. For example, look at the gap between this bolt head and the body of the bearing, and also some of the rubber on the old one is sort of spilled over the edge, almost like it's liquid. I knew that the springs were down, but obviously some of the car's sagging is apparently caused by this, just this rubber, at least a few millimeters. This is the new bearing unit, and that rubber mount just sits inside it like so, and that bearing is what rotates when you turn the steering. Now the new one feels nice and greasy to turn. So I would have just bought quick struts. That's where you get the whole strut assembly, the whole shock assembly. But I couldn't find any for the Mondeo, not that made any financial sense anyway. So I had to buy separate components. Here is the boot and bump stop kit, those bits that were missing in action from my old ones. And here's one of the springs. Now you can see how even with the weight of the car off the shock, the old spring there is still about half the length of the relaxed new spring, which tells us something about the amount of compression that's going to be required to get it assembled. More on that in a minute. Skipping ahead, here's one of my shocks disassembled. I want to show you this bearing. It just fell apart on disassembly, and the balls basically just fell out of their race. That's not where the balls are supposed to be. I mean, they just fell down there. You can see one or two up still inside, but the whole unit is just clearly destroyed. It's impressive that it was still turning as well as it was, to be honest. And I also found that my struts were shot. No surprise, really, but I had sort of hoped they might be okay, as there was no evidence of any fluid leakage ever. They should be difficult to push down and then pop back up on their own. This one's rather tired. And here's one of the new ones I got. You can see it takes a lot more force to push it down, and you can see how it behaves when you let it go. The boot and rubber stop kit took me a little while to work out which way round they go. And this aftermarket version didn't precisely match the old Ford ones. Not that there was much left of the old Ford ones anyway. There's a receptacle in the boot which the foam stopper fits into, and you have to sort of jam them together. I just used some silicone grease here to line the plastic and just make it easier to force in without damaging anything. And maybe that'll help the foam not wear so much when it's in use. It's the same on the upper side. The stopper has to fit into this ridge on the bearing unit. More silicone grease, and it just pushes in there. Then it's all assembled together, and the stopper will live at the top of the strut. And obviously it goes together like so, but of course there's one thing missing.
Mid-job break then, you can see I have a new toy here. This is the old spring. If you compare the length of that spring to the one that's compressed on the new strut, you can see that has to be compressed quite a lot, and it is rather strong. I mean, put quite a bit of weight on that, and it doesn't go down very much. Now you can get these spring compressors that as an amateur you can use for a lot of car springs, but they're just a threaded rod with a sort of slightly dodgy metal hook on either end, and I've read people using up to 5 around to get these ones down, because they're very strong, and as you can see you have to compress it a lot. And not only do you have to compress the whole length, but when you actually come to put those clamps on the spring, you could only sort of grip it there, and then around here you might only have like 1, 2, 3 to hook onto, which means that you're only working with maybe, if you're lucky, 2/3 of the spring's length, which means that these springs, the coils have to be so close to each other that they're almost touching by the time you can get the nut on and tighten it. And it's just dangerous, frankly, and I wasn't willing to muck around with it, so I didn't. I got a shop to assemble it. Bit of a story with that. The first shop I took it to was just a mechanic down the road, and number one, he gave up and told me to come and take it away. He didn't want to do it, even after having agreed to. And number two, when I realized what he was doing, he had tried to put the new springs on upside down. He was so convinced as to the orientation that he had used a paint pen to write top down here on the bottom. So I'm glad he actually didn't go ahead with that. And then after that, I took it to a shock specialist. So I recommend you do the same, unless you've got a good relationship with a mechanic that you trust to do it properly. Take it to a suspension place.
Apparently it's actually easy on these struts to make just that mistake. The springs should be labelled top and bottom, but a lot aren't. The only hint on these KYB springs that I got is the orientation of the little model number label, which way around does the text sit. The reason they're confusing is that they sort of look correct when they're wrong and look sort of wrong when they're right, when you place them in position. The springs are these asymmetrical banana springs, which are designed to control a bit of lateral shock as well as the obvious vertical shock forces. And their top and bottom mounting points are offset quite a lot from the central axis. So the spring as a sort of geometry is quite a lot more complex than you might think at first impressions. If you get yourself confused, it's helpful to have the old springs because you can match them up. This is one of my old ones. That's definitely the bottom at the ground because the color codes go there. What I noticed is these would want to fall over in a particular direction if I tried to balance them, whereas upside down they were a bit more stable. And then I found the same thing more or less with the new ones, so that's one bit of confirmation. Next, if I offered up the top mount bearing to the bottom of the spring, it sort of looks like it might fit, but the pigtail on the spring would have to be opened up a little bit. In other words, you would have to sort of force it together, whereas at the correct end at the top, it just sat in there easily. And you repeat that with the new springs, and you find the same thing. So, okay, second point of confirmation. And finally, to really make sure, I found that the two ends of the spring were offset differently. And this is how you really know. If I put the top mount in place and a straight edge held against the outside width of the spring proper, would clear the mount on all sides quite easily. But as you can see, if it's upside down, it's way over, and the ruler here does not clear on the one side. That's partly because my old spring's a little bit bent at the bottom. On the new one it does clear, but it's obviously much more offset as well. This is upside down, the right way up, and the clearance is how it should be. So I had to do this to make it doubly sure, and the final component I added here are these cheap rubber isolation sleeves which go at the bottom of the spring.
So at the shock shop, I had the discussion with the guy about all those things about the spring, and he agreed with me. And now you can see that it is on the right way up, which is progress.
On to the last stage of this project now. While the shocks are out, I gave the towers top and bottom a good clean. There's all sorts of crud that builds up, particularly where the top mount sits against the body. This is also the time to check carefully for corrosion if you're fighting rust. You also need to clean up the bolts if you're reusing them. If they're heavily corroded or the threads are damaged, they might need replacing. Mine were fine, but this factory thread locker needs taking off. Nothing a wire wheel can't handle. And I also used a wire brush on the inside of the strut clamp. And that's just brake clean that I'm using to rinse it down with. I put a bit of anti-seize where the top mount nuts go against the body, mostly because I couldn't be bothered painting the bits that had been chipped off, but also because I knew I'd be leaving these loose while putting things back together and the nuts move around and scratch the paint. Okay, on the new strut, or specifically the top mount, there should be, or there are, lines with arrows. This line is to point forward and back along the car. You can absolutely put the mount in the wrong way round if you're not careful, and then the mount will be oriented wrongly. It does matter because it's not a circular shape, it has some geometry to it. So check this. You can turn the strut at any time, of course, but if you align it all correctly to start with, then there will be less chance of getting confused when you actually put it in the car. The thing to do here is to get the shock hanging off those top mount nuts, but do not tighten the nuts at all. There wants to be plenty of slack to allow it to be swung around. In fact, I left the rear one off completely because it wants to swing so far forward that the thread on that spindle will come all the way out. So I put my spreader tool, my butchered bolt back in, and I used some of the same penetrating oil to lubricate things just to make this easier and also hopefully not scratch up the paint on the new strut. I like this oil because it seems to evaporate away after a while, and if it leaves a film, it's a very dry film and not greasy at all. It didn't seem like it to be a very good idea to use grease here, although you could possibly use anti-seize. And then I just had to fight with the whole thing to get the round peg in the supposedly round hole. It's a bit tricky, I will say. The hardest part is just getting it started so that it's aligned properly. And then the only awkward part is that unlike when removing, you're now fighting gravity to lift the wheel up onto the strut. The other thing I needed to be careful of is the CV axle. Once the ball joints are free, then there's nothing stopping you from ripping apart the tripod bearing, which you can see here. That boot is already rather stretched. Now this is because the whole thing is both down and out farther than it wants to be. If you pull it out too much, then the bearing inside there can just fall apart. There's nothing mechanically stopping it. And then you'll have problems later on. I tried to hammer it again, but it's much harder to hit from the bottom than the top, mostly because the axle shaft is directly underneath it. So the only place to smack it is this sort of flange on the side, which isn't the best place because you can't center your hammer strokes. So I smartened up and I put the jack on the same bit of timber on, and I lifted it up a bit. This worked, but you do have to be careful. I found that it would go a little bit, but because I was still having to apply the force on that flange on the outside, it would sort of jam and then start to push the wheel out. So I'd have to stop and give it a wiggle to straighten it up again, keeping the CV axle from being pulled out, just until it relaxed, and then repeat, and so on until it was up. You just got to work it up slowly. The other thing is that this strut does have to be aligned to the wheel. There's a prong on the inside, which is a bit difficult to see. It goes in the gap of the clamp once it's home. Finally, I got it that last little bit, last little wiggle, and then the spreader tool could come out and it will grip the strut tight. And before you do out the bolt, you want to check that locator is where it should be all the way home. In goes the bolt. This has new Loctite blue on it, by the way, and tighten it up. Careful again how you wrench on this. If you're pulling outward again, you could pull the whole assembly out too much. I torqued it before the Loctite could set. The spec on this is 83 Newton meters. And now it'll stay on there. Now I had to get the ball joint back in. This again is a danger zone moment for the CV axle. Don't pull the hub outward. It's important that the spindle is vertical, and once it's located up against the hub, I found that the best way to get it in is to just turn the wheel back and forward like so, as if you're steering it. If you try to hammer it in, it will not go, but if you get the rotational angle just right, it will pop itself up in there with no drama. It won't go all the way, but it will sort of get itself started. I always needed to hammer it home the last few millimeters. You do need to make sure the cutout for the bolt has come up into line with the bolt hole in the knuckle. New Loctite on that nut again, and the torque on the ball joint bolt is also 83 Newton meters. Now those CV axle tripod bearings should be safe, but once I had both side struts finished, I did check them. They looked okay at least, and they turned at both sides without any binding or noise. If you've done anything minor to them, then they might still seem okay at this stage, but then give problems while driving. Apparently you can get vibration during acceleration, so look out for that. Then it was just to put the calipers back on. I redid some of the brakes anti-seize here. This is brake job material really, so I'm skimming over it. The torque on the slider pin bolts for the caliper is 30 Newton meters. The last stage was to raise the subframe back up. Now, as the frame returns back to position, it should go back to where it was before, but since I'd changed both my arms and the suspension, it was actually a bit out and it needed some encouragement to pull it back into a line. Now the circle is quite obvious. There are holes at the inside which are for alignment pins, and technically you're supposed to use them. The Ford Workshop manuals instruct you to use the special pins, but it's really very easy to check visually because you can see the clean and dirty area where it's been all its life. Once you're happy, the big bolts go back in. Thread them all the way, and also don't forget about the little pressed steel brackets that go between. And get the little bolts at the back end too before you go torquing the main bolts, just to hold the position right. Then I tightened the front bolts back up. I didn't torque them just yet, but just to remove the gap that we introduced before and to get the geometry back level at all four corners. And then finally it's time for the big torque wrench again. The Ford spec for all of these big bolts is the highest in this job. It's 142 Newton meters. So lots of fun. Just make sure that socket is on dead square, but this time there is a lot of space for you to hold the socket end. So what you do is you push on that while you pull on the other end of the wrench, if that makes sense, and that will keep it all square. Same for the front ones, where you need that long extension again. That's kind of fun, honestly. And the 10mm bolts on the brackets are only 10 Newton meters, which is pretty low from one extreme to the other. And then that's it. Make sure you have in fact done all the bolts properly, but then the support can be lowered and removed. More work to do though. Back inside the cabin, the steering wheel shaft needs to be reconnected to the coupling. Before doing so, there's a maintenance job on these cars that involves lubricating the telescoping steering. They call it a compensator here with silicone grease. I did a video on that just years ago, if you're curious. Anyway, it's worth doing it again while all this is apart. And to position it correctly, you're supposed to use a 70mm long spacer like this at the top half, because the articulating connector doesn't find its correct position on its own. So with it guiding the height or the extension, you can flip this connector back in place. And by the way, the steering wheel should be centered, and so should the rack. Otherwise, this isn't going to work. So you could get yourself in a mess here, but yeah, I would have thought that's obvious. And then the bolt can go back in, more thread locker on here, by the way, and tighten it back up. It's a bit laborious because it's an awkward thing to access, and you're clamping the connector around the coupling shaft, so it doesn't exactly do up by finger, but you'll get there. And then at the end, the torque spec on this one is 20 Newton meters. Don't forget the other bits to reconnect. The restrictor on the gearbox has to go back in place. The torque on both of its bolts is 80 Newton meters. Don't do up the one before you've put it back into position and you're ready to tighten them both. And the downstream oxygen sensor plug, I'm just using some electrical spray here to clean and coat the connector while it's exposed. There's not really any need for that though. And clip it back in how it was on the subframe. Back to the struts. Remember I didn't tighten those top mount bolts. These need to be torqued with the car's weight on the suspension, but I did want to snug them up at this point so that nothing was loose. Finishing touches. Don't forget your Jaguar branded brake line bracket. Now, this nylock is fine to reuse, I think, but I just added some Loctite and I snugged it up prior to torquing them both. Now, the other one is the drop link bolt. Now, with this new spring and strut and everything, it no longer lined up as it needed to in my case. You could push the sway bar down just to get it right, but I just jacked up the spring slightly now that it was safe to do. So shouldn't jack on the rotor, by the way. I was just lazy. I should have used the control arm at the ball joint. Bracket with the ABS cable and the new nut. I say new because I've installed new drop links here too. So this is the new line lock that came with it, and no need for thread locker in my case. If you were again reusing the old nut, then use some Loctite. Torque wrench time. The spec on both of these nuts is 48 Newton meters. This is the ABS sensor connector. I cleaned these out both sides with contact cleaner first, just because they've been sitting disconnected for a while. And then I used some electrical protector spray, just because why not, and pushed it back in until it clicks. And then it was the moment of truth. The car can finally sit on its new shocks for the first time. I don't know what I expected, really. If it's all new and assembled properly, then this should be very undramatic. Now, the final job, not to be forgotten, was to torque those top mount nuts. They go to 30 Newton meters. And the reason you do this on the ground when the weight's on the car is the body or the chassis has two bits of steel which meet here. It's not just one. And you're compressing those together when you tighten them a little bit anyway. So the weight of the car will help with that compression. So if you torqued them without the weight, they'd end up under-torqued. So I just walked them around, getting tighter and tighter until they were correct. And that's it. It's been quite a project, this one. I suggest doing a careful test drive to check nothing's wrong. But this looks like a nice smooth suspension doing its job properly. Also, I did measure the car's ride height. Remember I said that the old springs were sagging, and it's now 30 millimeters higher. So that's quite a result. You will need an alignment for sure if you've you've disturbed the subframe and put new suspension components in. The alignment geometry will be different. So off to the alignment shop. Otherwise, that's it. Hope that was helpful. Have fun.